So this is just n times delta. Okay? So that delta so if I measure the first peak, or for that matter I take some other peak and I measure it, and I measure the n plus 1th peak after that particular measurement, I can still calculate the logarithmic decrement from experiments. This is from experiments now. Once I calculate it from experiments, then from basic theory, I have this following relationship. Then theory says theta is delta by I can calculate theta. This is extremely important because this is a powerful technique. You take anything, any physical system, I now have the capability, at least peripherally, and to a deeper extent as well, we now have the capability to model it as a second order system. The great news is if I model it as a second order system, I know what the solution strategies are. I take an excitation function f of t, I take the Laplace transform on both sides, put it into MATLAB, spit out something, and then analyze the system behavior. It becomes simple, it becomes elegant. Okay, I want to finish off by saying one more thing. This is just for an underdamped situation. What do you do if the system is overdamped? Do you repeat the same thing? You cannot. Because there is no logarithmic decrement there. There is just an exponential decay. But remember, and I'm going to have this in my lecture notes, and I'm going to have a problem on this, so please read the lecture note at least for this particular lecture. If I have an overdamped system response, the characteristic is governed by the time constant, the second order time constant. One by zeta omega. We discussed this in the last lecture. So by figuring out where the system is reaching approximately 2% of its steady state value, let's say it's reaching somewhere here. So here x of t is 0.02 times x steady state. Obviously steady state is 0. So if I'm reaching 0.02 times whatever the steady state value is, I know the time at that point. That's 4 times tau. So if I calculate that particular time, I know that tau is 1 by zeta omega n. I can calculate zeta because I already know omega n. Omega n is square root of k by m. This is a lot of stuff in probably 1 minute, which is why I have this elaborated in my lecture notes. You'll have a problem on this in the next homework set. Okay? Thank you.